Good day, viewers, and welcome to another moment of class. Thank you for watching this video. But before I proceed, I'd like to implore you that please that you try and subscribe to this channel, in order to fulfill the YouTube algorithm process, and then hit the like button so that when I upload videos like this, you can be notified. All right, like and share at the same time. Thank you. Now, I like to talk about calculating empirical formula, which is in chemistry. Calculating empirical formula. Now, I have a question on the board already, which we are going to start with. All right. Now, the question says that a compound contains 84% carbon and 16% hydrogen. All right. Find the empirical formula. Very simple. A compound contains 84% carbon, 16% hydrogen, and find the empirical formula. Now, but before I proceed, what is empirical formula itself? Now, empirical formula is the simplest formula which shows or expresses the number of different atoms, okay, different atoms of different elements that are present in a compound. Okay, it's a formula which shows the number of different atoms of elements that are present in the compound. So, as I proceed, we want to solve this. Now, the elements that are involved in the compound are carbon and hydrogen. Those are the elements involved in the compound. Then what are their percentage by composition? Their percentage by composition is carbon is having 84% and hydrogen is having 16%. Now, their atomic mass. Carbon has atomic mass of 12, hydrogen has atomic mass of 1. Now we are going to calculate the number of moles. Okay, we are going to calculate the number of moles. Calculating the number of moles, we have 84 over 12, and then we have 16 over 1. Alright, 84 over 12, and then 16 over 1. Now, because of space, let me just wipe up some of this question. Alright, so the number of mole, like I said, is 84 over 12, while that of hydrogen is 16 over 1. So if you divide this, definitely this is going to give you 16. Alright, and this is going to give you 7. Alright, that is going to give you 7. So what do? We divide by the smallest of it. So if we divide by the smallest, we have 7 divided by 7, and then we have, that's for carbon, and then we have 16 divided by 7. So if you do that, you have 1. This is definitely going to give you 2.29, I guess. So approximately, the empirical formula will be C, because carbon is 1, then this one is 2, CH2. That will be the empirical formula for carbon and hydrogen in that question. All right, now let's consider another question. I hope that is clear. Let's consider another question. This question says that uh, a mineral contains 14%, 14.7 calcium, okay, 14% calcium, then 67.7 tungsten. That's the symbol. Then we are told that the remainder of the earth minerals is oxygen. All right, the remainder is oxygen. So we are asked to find the empirical formula. All right. So of course, the elements involved, they are calcium, tungsten, and oxygen. Their percentage composition: calcium is having 14.7%, tungsten is having 67.7%, while oxygen is going to be 100 minus 14.7 plus 67.7, and that is going to give us what? That is going to give us 17.6. Okay, so that means oxygen is having a percentage composition of 17.6. All right, so the atomic mass for each of it, of course, we know that calcium has atomic mass of 40, tungsten has atomic mass of 184, and oxygen has atomic mass of 16. So from there, let me just wipe this. From there, we have a number of moles. The number of moles now is going to be 14.7 over 40. That's for calcium. Then for tungsten, it's going to be 67.7 over 184. And for oxygen, it's going to be 17.6 over 16. And so when we divide that, we have 0.37 for calcium, and we have 0.37 also for tungsten, and we have 1.11 for oxygen. And so at this point, we are going to divide by the smallest. Right? So when we divide by the smallest, we have 0.37 divided by 0.37. For tungsten, we also have that. And for oxygen, we have 1.11 divided by 0.37. So definitely this is going to give us 1, and this one is going to give us 3. So the empirical formula will be calcium, tungsten, That will be the empirical formula. CaWO3. That's the empirical formula. I hope that is clear. All right. Thank you. If you have any comments or questions, you can just put them down at the comment section. Thank you.